A shelf sits at ceiling height in a hospital resuscitation bay, mounted flush against the wall, above the level of the overhead lights. Its surface faces downward. The image placed upon it, a photograph, a symbol, arrangement of shapes and color, cannot be seen from the floor below, cannot be seen from the doorway, cannot be seen by anyone standing at the equipment cart, or the medication trolley, or the narrow bed positioned at the center of the room. To see what the shelf holds, a person would need to be above it. They would need to be looking down at it from a position that no one in the ordinary running of a resuscitation bay could occupy. The shelf was installed during a period when the room was otherwise quiet. A maintenance worker and a research coordinator from the participating hospital came in during a morning between scheduled procedures when the resuscitation bay was clean and empty and the overhead fluorescents ran their usual continuous white across every surface. The shelf went up with a few fixings into the wall bracket, was checked for stability, and was noted in the study documentation as installed. Then the room was restored to its ordinary configuration, the monitoring equipment arranged around the bed, the crash cart positioned at its marked point on the floor, the defibrillator charged and waiting on its trolley, and the shelf was left there at ceiling height, its image facing down at the floor, seen by no one. In the weeks and months that followed, medical staff moved through that room the way medical staff move through all such rooms, quickly, under pressure, attending to the person on the bed and the equipment surrounding them, not to the ceiling. Nurses who had worked in that bay for years would later be unable to say with any certainty whether they had ever noticed the shelf. A registrar who had participated in several resuscitations in that room recalled when asked that there had been something up near the ceiling but couldn't place it more precisely than that. The shelf existed in the peripheral vision of everyone who passed beneath it and in the active awareness of almost no one. That was the design. That was exactly what the design required. The study this shelf was part of had a name, a published protocol, a lead investigator, an ethics board approval number, and a set of participating hospitals stretching across 2 countries. Its formal title was AWARE-2, an acronym for Awareness During Resuscitation, second iteration, and it was designed by Dr. Sam Parnia, who held the Directorship of Critical Care and Resuscitation Research at NYU Langone Health, and who had spent the better part of a decade building the methodological and institutional infrastructure that AWARE-2 required. The shelf was central to that infrastructure. So was the ethics board. So was the structured interview protocol. So was the fact that the study enrolled patients at more than 25 hospitals across the United States and the United Kingdom, making it the largest geographically distributed study of recalled awareness during resuscitation that had ever been attempted anywhere. Parnia had not arrived at this work casually. The questions that AWARE-2 was built to address had occupied clinical researchers for decades before the first shelf was mounted, and the methodological limitations of earlier work, smaller sample sizes, inconsistent interview protocols, insufficient distribution of ceiling-mounted target equipment, had been documented carefully in the literature. AWARE-2 was shaped, in a very direct sense, by the lessons of what hadn't worked before, by the coverage gaps in earlier ceiling shelf installations, by the variability in interview methods, by the difficulty of reaching patients quickly enough in the recovery period to capture their accounts before memory degraded or before the accounts became shaped by what patients had subsequently read or heard about their own resuscitations. The design of AWARE-2 addressed each of these problems in turn. It did so with the kind of institutional patience that long-form clinical research requires, a patience measured not in weeks or months, but in ethics applications, and training cycles and site-by-site installation schedules spread across 2 countries. The ethics board oversight was not incidental to the work. A research project examining the experiences of people who had been clinically dead and were now recovering from cardiac arrest occupied a space that required careful management of patient vulnerability, informed consent, cognitive assessment, and interview timing. The signed approvals arrived in sequence: NYU Langone's institutional review, the UK ethics applications at participating NHS trusts, the site-specific governance documents at each of the more than 25 hospitals. These documents accumulated in folders, signed across their signature lines, one set at a time, the institutional letterhead of each organization printed above the authorization. A stack of these folders, held in an administrative office at NYU Langone, represented something real: the accumulated permission of multiple institutions in multiple countries, each of them having reviewed the protocol and concluded that this work was worth conducting within the bounds of appropriate care for the people it would ask to participate. The patients who would be asked to participate faced a specific and stringent threshold for eligibility. A person could only enter the AWARE-2 study if they had survived an in-hospital cardiac arrest and recovered sufficient cognitive function to engage with structured interviews. Both of those conditions were harder to meet than they might sound. In-hospital cardiac arrest carries a survival rate that varies by setting and circumstance, but consistently stays below 25% of patients who experience it, meaning that for every 4 people whose heart stopped in a participating hospital during the study period, at least 3 would not survive to be eligible for anything. Of those who did survive, not all would recover the cognitive clarity required to participate in the interview protocol within the window the research design required. The eligible pool, the small fraction of small fractions, who had survived and recovered well enough to sit with a researcher and describe what, if anything, they had experienced, was always going to be limited in size. This was not a flaw in the design. It was a condition of the subject matter, documented clearly in the published methodology, and it shaped the statistical expectations the research team carried into the analysis phase. To be interviewed at all, a patient had to have come back from a place that fewer than 1 in 4 people come back from. The research coordinators who conducted the interviews understood this. They had been trained in the 2-phase protocol that AWARE-2 used: an open-ended initial phase, followed by a structured phase using the validated Grayson NDE scale, and they were responsible for conducting those interviews with both consistency and care for patients who were, in many cases, still fragile from their clinical event. The work of a research coordinator in this study meant walking quiet hospital corridors between the intensive care unit and patient recovery rooms, carrying a printed interview protocol and a voice recorder, knowing that the person on the other side of the door had, some days or weeks earlier, been clinically dead. The knock on the door was unhurried. The recorder was placed on the bedside table, not in a patient's hands. The protocol's first phase asked open questions and then waited for whatever came back. What came back, or didn't, was the data. The shelf at ceiling height was connected to a specific and carefully considered research question that had, in various forms, preoccupied clinical researchers for years. If a patient, during a period of cardiac arrest, when their brain was not receiving oxygenated blood, and their heart had stopped producing any measurable output, nonetheless experienced something, perceived something, heard something, observed something, then the question of where that perception had been generated was not a small one. It could not be easily absorbed into existing neurological models. It pointed instead towards something that those models did not account for, and it raised the further question of whether the something that had been perceived corresponded to anything that was actually present in the room. The shelf addressed this second question with a precision that no interview alone could achieve. An interview could capture what a patient described. It could record the language they used, the details they mentioned, the sequence of events as they remembered it. But an interview could not by itself confirm that any of those details were accurate to what had actually occurred in the room during the arrest. A patient might describe the ceiling. They might describe the positions of people in the room. They might describe sounds or words or objects. All of this could be gathered and documented. The question that the shelf was designed to help answer was the harder one: whether any patient, during or immediately following their cardiac arrest, reported perceiving something that they could not have known about from their floor-level position in the bed. Something, specifically, that was only visible from above, from a vantage point that no one in the ordinary operation of the room would occupy. The image on the shelf was the test. A patient who described the ceiling shelf, who described what was on it, would have provided something beyond a verbal account of an experience. They would have provided a verifiable claim, a claim that could be checked against the actual contents of the shelf, against the layout of the room, against the record of what had been installed and when. The shelf existed so that this check could at some point become possible. The installation of shelves at ceiling height in resuscitation bays at participating hospitals was not a simple logistical matter. Each site required its own installation schedule, coordinated with the clinical operations of the bay and the availability of the maintenance personnel who could do the work. Some shelves went up early in the study period, in hospitals that had been involved in earlier phases of the research and already had their governance documentation in order. Others went in later as new sites joined the study. The distribution of installations across more than 25 hospitals in 2 countries produced, over time, a network of waiting shelves and waiting rooms, each one installed and documented, each one positioned at ceiling height, with its image facing down at the floor, each one invisible to the staff who passed beneath it, and to any patient lying in the bed below. The scale of aware, too, distinguished it from everything that had come before it. Earlier investigations of recalled awareness during cardiac arrest had been conducted at single institutions or at small clusters of hospitals, and the resulting sample sizes had consistently limited what could be statistically concluded. A finding from 50 patients at one hospital was interesting. A finding from 50 patients at 3 hospitals was more robust. A finding gathered across more than 25 hospitals in 2 countries, with consistent protocol application and centralized data management, was a different kind of evidence entirely. Parnia and the research team had built the study to the scale that its research questions required, not larger than necessary, not so ambitious that the methodology would buckle under its own logistics, but large enough that what it found would be difficult to attribute to the particular characteristics of any one site, any one clinical culture, any one patient population. The United States and the United Kingdom were chosen for reasons that combined practical and methodological considerations. Both countries had hospitals with established resuscitation teams, consistent reporting standards for cardiac arrest events, and institutional research infrastructures capable of supporting multi-year clinical studies. Both had ethics review processes that the research team could navigate with the experience gained from earlier work. The combination of American and British sites also meant that patient populations with different demographic profiles, different healthcare contexts, and different cultural backgrounds would be represented in the data, a diversity that strengthened whatever patterns the interviews eventually produced. At NYU Langone Health, where the study was directed, The administrative infrastructure for a project of this scope was not assembled quickly. The IRB documentation alone represented months of preparation, the research protocol written and reviewed, the interview instruments validated and standardized, the data management plan developed, the training materials for research coordinators across all participating sites produced and distributed. The lead up to the first patient interview was a long period of forms and meetings and preparatory correspondence between institutions carried out in the background of ordinary hospital operations, noticed mostly by the people directly involved. A manila folder on a desk in a research office holds what that preparatory period looked like in paper form. Ethics approval documents, their signature lines filled in across multiple months, their institutional letterheads representing the array of hospitals and review boards that had examined the protocol and signed on to it. The folder is not a dramatic object. It is the kind of object that accumulates in the administrative lives of all large clinical studies, dense with procedural language, organized by date, carrying in its ordered pages the evidence of how much institutional agreement it takes to build a study that can ask the questions. Where to was built to ask, the clinical context in which the study operated was one that most people prefer not to think about in any detail. An in-hospital cardiac arrest is an emergency in its most compressed form. A patient's heart stops. The resuscitation team mobilizes. Chest compressions begin, maintaining some degree of circulation. A defibrillator is brought and used if the cardiac rhythm permits it. Medications are drawn and administered. Multiple people occupy the room simultaneously, each performing a specific task in a sequence that has been drilled and practiced until it runs automatically, because in a resuscitation, there is no time for hesitation or improvisation. The sounds of that room, the mechanical percussion of compressions, the voices of team members calling out observations and instructions, the beeping of the cardiac monitor fill the space where the patient lies unresponsive. The ceiling above them, unreachable. The overhead lights in a resuscitation bay are steady and white. They do not flicker. They are engineered for clarity, for the visibility of surfaces and instruments and the patient's skin, and they produce a consistent, even illumination that leaves nothing shadowed that the clinical team might need to see. Under those lights, the narrow bed is the center of the room's attention, and the ceiling above it is simply the top of the space, a surface that holds the ventilation fixtures and the overhead light panels, and in the participating hospitals of Aware 2, a shelf that most of the people in the room had stopped noticing weeks after it was installed. The research team's data collection was coordinated centrally, but the work of it happened locally, at each of the more than 25 sites, in the hands of the trained coordinators who were responsible for identifying eligible patients, obtaining consent from those who were able to give it, and conducting the interviews within the time frame the protocol required. The voice recorders they carried were digital, their batteries checked before each interview. The printed interview protocols were paginated and hole-punched, kept in binders, carried in the same bag as the consent forms and the Grayson NDE scale copies. A coordinator walking the corridor between the ICU and a recovery room was carrying all of this, and was also carrying, less tangibly, the awareness that the person they were about to speak with had experienced something that the clinical team had successfully reversed, and that what the interview was attempting to determine was what, if anything, that person had experienced during the interval in which the reversal was happening. This is the specific quality of the work that makes the study's design so careful. The question it was asking sat at the intersection of clinical medicine and something medicine does not have fully adequate language for. When a patient's heart stops and resuscitation is begun, There is a period in which the usual markers of consciousness, electrical brain activity, responsiveness, reflex, are absent or severely diminished. The clinical category for this is cardiac arrest. The experiential category, for those who emerge from it with memories, has no agreed clinical name in the literature of the period when Aware 2 was designed. Parnia's earlier work had already noted this gap. The study was designed, in part, to fill it with documented, structured, reproducible data rather than with anecdote. The data collection period extended across multiple years. Hospitals enrolled patients, interviews were conducted, transcripts accumulated, and the research team worked through the methodological requirements of a study whose sample was limited not by choice, but by the hard biological fact that most cardiac arrest patients do not survive. The patients who were interviewed, the ones who had crossed that threshold and come back with enough cognitive recovery to sit with a voice recorder on a bedside table and answer structured questions, represented a very particular sample of a very particular event. They were the ones who had made it. They were a small fraction of all the people in all the participating hospitals whose hearts had stopped during the study period. And among them, the ones who had anything structured to report about the experience of their cardiac arrest were a smaller fraction still. The study's primary findings were eventually submitted to a peer-reviewed journal. The journal was Resuscitation, the official publication of the European Resuscitation Council, published in the Netherlands, indexed across the major scientific databases, but carrying the institutional standing of a publication that exists at the intersection of clinical cardiology and emergency medicine. The Aware 2 paper appeared in its pages in 2023, completing a publication trajectory that had begun with the ethics applications years earlier and had moved, step by step, through data collection, analysis, independent review, manuscript preparation, and the peer review process, through which the journal's editors and external reviewers assessed the work before it went to print. The 2023 issue of Resuscitation, in which the Aware 2 paper appeared, is not a large or visually striking document. Scientific journals are not made for visual impression. The cover design, gold and navy, the journal's standard colorway, is a small practical thing designed to be recognized rather than admired. Inside, the pagination is dense, and the text is set in the small, efficient type that scientific publishing uses to carry as much content per page as the format allows. The Aware 2 paper begins on its assigned page and runs through its sections in the standard sequence of clinical research: introduction, methods, results, discussion, conclusion, references. The methods section describes the shelf installations. The results section reports what the interviews yielded. The discussion holds both of these things carefully against each other and against the existing literature, and it does not reach further than the data permits. The paper represents the arrival of something that had taken a long time to build. The ethics approvals in their manila folders, the shelf installations in their more than 25 resuscitation bays, the training of research coordinators across 2 countries, the interviews conducted at bedsides and hospital recovery rooms, the transcripts prepared and reviewed and classified, all of it moved, over the years of the study's operation, toward the production of this document. The journal's page, its text running in neat columns, its figures and references properly formatted, is where the infrastructure of the study came to rest. A person reading the paper on a desk in early 2023, the journal lying open, the pages flat, the text available in the way that published text is available, fixed, indexed, reproducible, would find it calm in the way that good clinical research is calm. It does not claim more than the data supports. It does not minimize what is genuinely unusual about the findings. It describes a study that was built to a specific methodological standard, conducted across 2 countries at more than 25 hospitals, and completed within a framework of full ethics oversight and structured, validated measurement. It describes, with the plain language of a peer-reviewed methods section, a ceiling shelf that was mounted in a hospital resuscitation bay, its hidden image facing downward, waiting for the world on the floor below to send occasionally someone back up from the edge of it. The year on the cover of the journal is 2023. The paper begins on its assigned page. The shelf is described precisely in the methods, with dimensions and installation protocol, and the reasoning behind its placement at ceiling height, rather than anywhere a patient could see it from the bed. The reasoning is stated as clearly as anything in the document, which is to say, clearly and without elaboration, because the reasoning is itself entirely plain. A person lying in a resuscitation bay cannot see the surface of a ceiling height shelf from below. If that person later reports seeing what is on the surface of that shelf, the question that report raises cannot be answered by the methods of any study built on smaller scale, shorter duration, or more limited geography than this one was built on. The study took years. It ran across more than 25 hospitals. It earned its ethics approvals one signed document at a time. Its research coordinators walked their corridors and knocked their doors and placed their voice recorders on their bedside tables and asked their open questions and waited for whatever came back. Its shelves sat at ceiling height in rooms where extraordinary things occasionally happened to ordinary people, in rooms that smelled of antiseptic and were lit from above by steady white fluorescent light, in rooms where the narrow beds were the center of everything and the ceiling was simply the top of the space. The paper that this work produced lies open on a reading desk in early 2023, the gold and navy cover of Resuscitation face up beside it, the Aware To text beginning at the top of its first column. Something built across 2 countries and several years had arrived, at last at a printed page. The page does not move. It does not require resolution. It sits in the open access record of its journal, available in the way that indexed scientific literature is available, persistently, without urgency, held in the archive of a field that has been building toward this kind of evidence for a long time. The shelf at ceiling height in the resuscitation bay is still there, in the rooms where it was installed. The rooms continue their work. The overhead lights run their steady white. The image on the shelf faces down at the floor, at the narrow bed, at the space below it where the clinical work happens, and where occasionally something else happens too, something that the study documented with as much care as its methodology permitted, and then committed to the printed record of its field for whoever comes after. A research coordinator in a hospital in the United Kingdom sat at a small desk with a stack of printed interview transcripts and worked through them one by one. The transcripts ran to several hundred pages in total. Most of the accounts in them described nothing at all, a blank, an absence, the experience of cardiac arrest as no experience, a gap between one moment and the next with nothing held inside it. The coordinator made notations in the margins as she read. Most of the notations were brief. Then, at a particular page in a particular transcript, the notation took longer to write. What the research team was working toward, across all the enrolled sites and all the recovered patients who agreed to be interviewed, was a count, a careful count built from structured questioning and independent review of how many of those patients recalled anything at all from the period when their hearts had stopped and resuscitation had been underway. The count, when it was finally assembled across the full cohort, produced a figure that the published paper described as approximately 1%. 1% of the enrolled survivors who were interviewed reported explicit recalled awareness of the resuscitation process as it was actually occurring around them, not a vague impression, not a fragment of a dream, displaced from some other moment, but a structured, sequential recollection of events happening in the room during the period of cardiac arrest. The research team treated this figure not as an anomaly requiring explanation, but as a reproducible finding consistent with estimates from earlier and smaller studies conducted across different hospitals in different countries in different decades. The number was small. The number was stable. Those two facts together were the finding. To understand what that 1% described, it helps to sit with what the other 99% described first. Cardiac arrest is not, for the majority of people who survive it, a remembered event. The brain, under the condition of arrested circulation, loses the capacity to encode new memory with extraordinary speed. The gap in conscious experience begins, for most people, before the event has finished. When they come back, when circulation is restored, and the clinical team hands them over to a recovery ward, there is simply nothing there. Not darkness, not silence, not even the sensation of absence, just a discontinuity, a moment before and a moment after, with no reported content between them. The research interviews confirmed this across the great majority of cases. The coordinator's brief marginal notations, a letter or two, a small check mark, recorded that the account was reviewed, classified, and filed. The vast majority of those files held the same essential fact: nothing recalled. Within the 1% where something was recalled, the accounts varied in their richness and in their specificity. Some patients described auditory impressions, voices, sounds, the particular quality of the sounds made by resuscitation equipment. Some described a sense of position in space, a feeling of elevation or displacement from their physical body. Some described both, their accounts moving between the auditory and the spatial, as though the two dimensions of the experience had been happening in parallel. The research protocol had been designed to capture all of this without steering it. The first phase of the interview was open-ended questioning, broad and unhurried, an invitation to describe whatever the patient recalled without suggesting any particular category of experience. The researcher asked what the patient remembered. The patient said what they remembered. The recorder on the bedside table between them turned slowly and quietly and captured every word. The open-ended phase was followed by the second phase of the protocol, in which the Grayson NDE scale was administered. The scale is a 16-item instrument arranged across 4 clusters: cognitive, affective, paranormal, and transcendental, with each item scored on a 3-point scale. A patient whose account scored above a designated threshold was classified as having reported a near-death experience in the formal clinical sense. Not all accounts of recalled awareness met that threshold. Some patients described hearing or perceiving things during resuscitation without reporting the other experiential features. The scale is designed to capture the sensation of moving through a tunnel, the perception of light, the feeling of peace or boundary or presence. The protocol distinguished between these categories carefully. Recalled awareness was one thing. A scored near-death experience was another thing. Both were documented. Neither was conflated with the other. All interviews were recorded. All recordings were transcribed. All transcriptions were reviewed by independent assessors who classified each account without reference to the primary researcher's classification. Where the independent assessors agreed, the classification stood. To Eneth. Where they disagreed, the account was reviewed again, discussed, and resolved through a defined adjudication process. This layering of independent review was part of the methodology's design from the beginning, not a response to any controversy that arose during collection, but a built-in feature of the protocol intended to ensure that no single reader's interpretation could determine the outcome of any single account. The stack of transcripts the coordinator worked through was part of that process. The notations in the margins were part of that process. The classification on the final page of each transcript was part of that process. The system was slow and deliberate and produced, at the end, a record in which every classified account had been read by more than one pair of eyes. In the years of the study, across the participating hospitals in the United States and the United Kingdom, there were accounts that crossed the threshold of specificity the research team held as meaningful. These were the cases that took longer to review. These were the cases where the marginal notations grew longer and where the adjudication process was engaged most carefully. Two cases in particular came to be cited in the published findings as illustrative of what the study had collected at the end of the scale, where the recalled details were most precise and most verifiable. The first of these cases involved a patient who reported, several days after resuscitation, that during the cardiac arrest, they had perceived themselves as elevated above the resuscitation bay, looking down, from above, at the activity being conducted around their body on the bed below. The account was not a vague impression of upward displacement. It was specific. The patient described the sequence of events they observed from that elevated perspective. Not a static image, but a moving one, a sequence with a before and an after, with actions following other actions in a documented order. The patient described the number of people present in the room. The patient described specific actions being performed during CPR. The patient described the position and arrangement of the people around the bed. All of these details were subsequently reviewed by the research team against the resuscitation record, the contemporaneous documentation that the clinical team had produced in the course of the arrest itself, noting times, personnel, actions, and sequence. The review was conducted after the interview, not before it. The patient's account was in the file before the research team picked up the resuscitation record to compare against it. The resuscitation record showed that the sequence of events the patient described was consistent with the documented sequence. The number of personnel the patient reported matched the documented count. The specific actions the patient named were among the documented actions performed during the arrest. The research team did not, in the published paper, describe this as verification in the strongest sense. The documentation of a cardiac arrest is not identical to a video recording of every movement and every spoken word, and the match between account and record was assessed as substantial rather than perfect. The published characterization was that the patient's recalled details were reviewed against resuscitation records by the research team, and that the account was consistent with the documented events in ways that the team found notable. The assessment stopped there. The published paper held the case at that level. The research team did not go further in print than the evidence warranted. The second case held a different character from the first. Where the first case was primarily visual and spatial, centered on what the patient reported perceiving from an elevated position, the second case was primarily auditory. The patient recalled hearing a specific comment made by a medical professional during the resuscitation, a comment about the patient's prognosis. The patient recalled not only that a comment was made, but something of its content or its nature, the general direction of what was said about their condition in those minutes. The patient was recovered. The patient was in a hospital room several days later. The comment, if it had been made, would have been made in a resuscitation bay over a patient who was clinically dead at the time, in a room that was not quiet, where other sounds were being produced by equipment and by the activity of the clinical team. The research team, as part of the follow-up process, made a query, a structured printed query, sent to participating staff at the hospital, asking whether staff could confirm the general nature of communications that had occurred during the resuscitation. The follow-up was careful and limited. It did not present the patient's account and ask staff to confirm or deny it directly, because that framing would have introduced the risk of inadvertent suggestion. It asked more broadly whether communications of the kind the patient recalled would have been consistent with what typically occurred during such a procedure. The response from staff confirmed that the general nature of the communication the patient described was consistent with what had taken place, not word for word, not a full corroboration, but consistent in a way that the research team found worth documenting with what had been recorded in the patient's account. Both of these cases occupied a particular position in the AWARE-2 dataset. They were not the only cases of recalled awareness in the study. They were the cases where the recalled details were specific enough and the subsequent review was sufficiently structured to allow a formal comparison between the patient's account and the available documented record. Most recalled awareness accounts did not lend themselves to that kind of comparison. A patient who recalled a feeling of elevation or a sense of light or a perception of peace was describing an interior experience that the resuscitation record could not address either way. The record documented what the clinical team did and when. It did not document what the patient experienced. The two cases that went to structured comparison were the cases where the patient had described something external, something that had in principle an independent record against which it could be checked. The research team was precise about the limits of what the comparison had established. The published paper did not describe the two cases as confirmed veridical perception. It described them as instances in which recalled details had been reviewed against the available record and found to be consistent with documented events. That phrasing carried a specific weight. It meant something more than coincidence and something less than proof. It placed the cases in the record as findings that warranted further investigation, which is a particular category of scientific statement, not a claim to have resolved a question, but a claim to have established that the question is worth asking with better tools and in a larger data set. The size of the 1% figure was itself one of the most discussed aspects of the published findings. 1% of the enrolled cohort reporting explicit recalled awareness of the resuscitation process was a small number in absolute terms, and a figure that demanded careful handling in the analysis. The study enrolled patients across more than 25 hospitals over several years. The absolute number of patients who met the eligibility threshold, survived an in-hospital cardiac arrest, recovered sufficient cognitive function to be interviewed, was itself a fraction of the total number of cardiac arrests that occurred in participating hospitals over the study period. The survival rate for in-hospital cardiac arrest is low. The proportion of survivors who met the cognitive recovery threshold for interview participation was lower still, and within the population who were interviewed, 1% reported recalled awareness. This was not a finding generated from a large population who all had the relevant experience. It was a finding generated from a carefully filtered population at the end of a very narrow funnel, and the 1% who reported recalled awareness were 1% of a group who had already survived something that most people do not survive. The implication of the figure being reproducible, consistent with earlier smaller studies, stable across different methodologies and different populations, was that it reflected something real about the phenomenon, rather than a methodological artifact. If 1% of cardiac arrest survivors consistently report recalled awareness across many different studies conducted by many different research teams in many different countries, that consistency is itself a datum. It says something about the phenomenon, regardless of what interpretation one places on it. The figure is small enough that it would be easy to dismiss in any individual study. It is consistent enough across the literature that dismissal becomes harder to justify on purely statistical grounds. The Aware 2 paper placed the 1% figure in that context explicitly, situating it in relation to the earlier estimates it was consistent with and treating the consistency as part of the finding. The structure of the two-phase interview protocol was worth understanding in its detail, because the detail was not incidental to the findings. The open-ended first phase served a specific methodological purpose. It allowed the patient to produce an account before any specific categories were introduced. If a researcher administers a near-death experience scale to a patient before asking them to describe their experience freely, the scale itself may shape the description. The patient, having answered questions about tunnels and light and the sensation of moving toward a boundary, may find that their subsequent free account is inflected by those categories, whether or not they actually apply. The Aware 2 protocol placed the Grayson scale second, after the open account had been given and recorded, precisely to prevent that contamination. The two phases were in a specific order for a reason that went all the way down into the structure of what the study was designed to measure. The voice recorder on the bedside table between the researcher and the patient was not a small detail. It was the mechanism by which the open-ended account was preserved in a form that could be reviewed by people who were not present for the interview. A researcher who interviewed a patient and then filed a written summary of the account would be producing a filtered version of the account, filtered through attention, through memory, through the categories the researcher held as salient. A recording captured the account before any filtering had occurred. The transcription of the recording was itself a version of the account, slightly removed from the original, but a version that could be checked against the recording if any discrepancy arose. The independent assessors who reviewed the transcripts were working at one further remove from the original account, but they were working from a document that had been produced by a fixed and auditable process. The chain from patient's spoken words to assessed and classified transcript was documentable at every link. The Grayson NDE scale that formed the second phase of the interview protocol had been in continuous use since its first publication in 1983. It had been validated across multiple populations and multiple languages. It had been used in the Van Lommel study published in The Lancet in 2001, in Kenneth Ring's Omega Project research, and in dozens of smaller institutional studies conducted over the intervening decades. By the time Aware 2 administered it as part of its structured interview protocol, it had a published history long enough that the scores it produced in the Aware 2 cohort could be placed in relationship to the scores reported in the earlier literature. A score of a particular magnitude in an Aware 2 patient interview was not a datum that existed in isolation. It was a datum that could be situated against 40 years of scored accounts from different studies, different hospitals, different countries, and different researchers. That situating was part of what made the instrument useful. Patients who participated in the interview process were in various stages of physical and cognitive recovery at the time of the interview. The protocol required sufficient cognitive recovery to participate in structured questioning, but sufficient cognitive recovery existed on a spectrum, and the interview process was designed to accommodate patients who were still fatigued, who were still adjusting to what had happened to them, who were processing not only the experience they were being asked to describe, but the medical event itself, the fact of having had a cardiac arrest, the fact of having been resuscitated, the fact of waking up in a hospital bed with the clinical story of what had happened slowly being assembled for them from the outside. The research interviews were not interrogations. The researcher who sat at the bedside with the voice recorder between them on the table was trained in the protocol and in the particular requirements of this population. The open-ended phase was designed to give the patient space, not to press them into a particular category of response. Some patients, in the open-ended phase, described their experience in terms that placed it firmly outside the clinical moment. Dreams reported from the period of recovery, familiar imagery from memory, fragments that the patient themselves was uncertain about and presented with uncertainty. The classification process distinguished these accounts carefully from recalled awareness in the specific sense the study was designed to measure. The study was measuring explicit recalled awareness of the resuscitation process itself, not recalled experience adjacent to the resuscitation, not imagery produced during the early stages of recovery, not a retrospective narrative the patient had constructed from what they later learned had happened. The distinction mattered enormously to the validity of the classified accounts. A patient who had been told afterward what had occurred in the resuscitation bay could describe those events accurately without having perceived them during the arrest. The open-ended interview protocol and the subsequent comparison against the resuscitation record were both designed in part to identify and exclude that possibility where it could not be ruled out. The two cases that went to structured comparison had been assessed with that possibility specifically in mind. In both cases, the research team reviewed not only the consistency of the recalled account with the documented record, but also the plausibility of the account having been constructed after the fact. For the first case, the patient who described observing the resuscitation from an elevated position, the details described included the number of personnel present and the sequence of specific CPR actions. Information about the exact number of personnel and the specific procedural sequence of a particular resuscitation is not information that is routinely communicated to patients during recovery. It is not in a discharge summary. It is not something a patient would be told as part of a standard clinical debrief. The research team noted this in their review of the case. They did not describe it as conclusive. It was possible in principle for this information to have reached the patient by some route not identified during the review. But they noted it because the noting was part of what the record was for. The second case, the patient who recalled hearing a comment about their prognosis, had a different character in this respect. Patients are often informed of aspects of their prognosis during recovery. A patient who was told in the days after the arrest that staff had discussed their chances during the procedure might construct a recollection of having heard that discussion, even if no such perception had occurred. The follow-up query to staff was designed in part to assess this possibility, to understand what the patient might have learned from clinical communications after the arrest that could have been the source of the recalled account. The staff response confirmed that the general nature of the communication was consistent with what had occurred, but the study did not find direct evidence that this specific information had been communicated to the patient during recovery in a form that would account for the recalled account. The case remained classified as a finding consistent with recalled awareness, documented as such, and held as an open question in the published record. The published paper, when it appeared in Resuscitation in 2023, placed both cases in the record with exactly that level of detail and exactly that level of qualification. The paper did not claim that either case had established veridical, out-of-body perception. The paper described what the patients had reported, described the comparison that had been conducted between the accounts and the resuscitation records, described the degree of consistency found in each case, and described what the research team had and had not been able to establish about the possible sources of the recalled information. This is how a careful study presents a finding that exceeds the strict threshold of proof while remaining within the standards of documented scientific reporting. The case is placed in the record. The comparison is placed in the record. The limit of what the comparison established is placed in the record, and the record is submitted to a journal, reviewed by independent referees, revised, and published. The independent assessors who reviewed the transcripts in the classification process worked from printed double-spaced transcriptions. Each transcript was paginated. Each page carried the interview identification number at the top. The independent assessors read the account and made their own classification without access to the primary researcher's classification and without access to the resuscitation record for the corresponding patient. Their marginal notations were made in the space the double spacing left between the lines of text and in the wider margins at the sides of the pages. Some of these notations were single letters, indicating classification category. Some were short phrases indicating the basis for a classification judgment. Some were questions, a notation that a particular phrase in the patient's account was ambiguous in a way that required adjudication. All of these markings survived in the research files alongside the transcripts they had been made on. The patient in the first of the two structured comparison cases had been in a recovery room in a participating hospital when the researcher knocked and came in with the voice recorder and the printed interview protocol. The patient was sitting upright in the bed. The voice recorder was placed on the bedside table between them. The open-ended phase of the interview began. What the patient described in that room, speaking slowly and specifically to the researcher, was a sequence of events they had perceived from a position above the resuscitation bay, a position their body had not occupied. The recorder turned. The words were preserved. Later, the transcription was produced. Later still, the independent assessors added their notations to the margins. The research file was assembled. The file was closed. The file was placed in sequence with the others. It is a quiet thing to hold, the image of that file in its sequence with the others. The majority of those files, the 99%, held accounts of nothing recalled, a blank, a discontinuity with no content. One file in 100, roughly, approximately, consistently, held something different, not identical from case to case, not the same account repeated, but an account in which something of the resuscitation room had been perceived and retained and later described in a structured interview with a voice recorder running on the bedside table in a language that was then transcribed and reviewed and measured and placed into a written record. The transcribed account on its double-spaced pages, the independent assessor's notation in the margin, confirming the classification, the file closed and set down beside the others. This is what 1% looked like, collected in print in the documented record of a study that had spent several years and more than 25 hospital sites building a methodology careful enough to hold it. In a hospital intensive care unit in Ann Arbor, Michigan, monitoring equipment ran its continuous record through the night. The EEG electrodes were in place on a patient's scalp. The machine printed its fine, wavering lines onto the scrolling trace, the expected rhythms of a brain still at work, the familiar oscillation of ordinary wakefulness moving into the slower architecture of rest. Then, at the moment of cardiac arrest, the trace changed. What it did next was not what the researchers had anticipated finding when they later reviewed the data. What it did for a brief and measurable window was produce a surge of gamma frequency activity so dense and organized that it exceeded, in some of its features, the neural signal of a brain fully awake and alert, and it did this in the seconds and minutes after the heart had stopped. The research team at the University of Michigan was led by Dr. Jimo Borjik, a neuroscientist whose earlier work had already placed her at the edge of what the instruments could reliably interpret. The 2023 paper, published in the Proceedings of the National Academy of Sciences, described 4 patients who had been monitored continuously with electroencephalography during the dying process in a hospital ICU. 2 of those 4 patients produced, after cardiac arrest, the kind of gamma oscillation surge that the EEG equipment was designed to record, but had not been expected to find at that moment. The finding was specific. The finding was measured. It was printed in the figure section of the paper, the 2 traces placed side by side, the vertical line marking the moment of cardiac arrest, drawn across each graph in a position that made the subsequent activity clearly visible to any reader who knew how to read an EEG record. Gamma oscillations fall between 25 and 100 hertz. In the language of neurological measurement, hertz refers to cycles per second, and gamma represents the fastest, most organized form of electrical synchronization the brain is known to produce during ordinary waking life. It is associated with complex cognitive processing, with perceptual integration, with the kind of unified conscious experience that allows a person to recognize a face, hear a piece of music as whole, rather than as disconnected notes, or hold in mind the relationship between several things at once. These are not the slow rolling waves of deep sleep, nor the irregular scatter of drowsy rest. They are the signal of a brain fully engaged with something. What the University of Michigan data showed was that in 2 of the 4 monitored patients, the dying brain produced this signal, produced it at levels that in some patients exceeded those recorded during their normal waking periods, precisely at the point when clinical function was ceasing. The surge did not last long. It arrived within seconds to a few minutes of cardiac arrest onset, a brief and sharply defined spike of organized neural activity rising out of the cessation of normal brain function. Then the trace returned to silence. The flatline EEG that followed was exactly what cardiac arrest physiology would predict. The quiet afterfunction stops. But between the arrest and the silence, the instruments had recorded something else, something organized, something that the published data placed in the record of 2023 and left there, measured and unrepeated, and precisely as found. The region of the brain where the surge concentrated was not distributed evenly. This detail was, in the view of the researchers who wrote the paper, among the most notable features of the finding. The gamma activity was not scattered across the cortex in the way a random electrical event might be. It was concentrated specifically in what neuroscience refers to as the posterior cortical hot zone, a region spanning the occipital lobe at the back of the skull, extending into the parietal lobes on either side, and reaching into portions of the temporal lobes below. In the language of published brain diagrams, this region is often shaded and bracketed separately from the frontal cortex, because its functional role in conscious experience has been specifically proposed and debated across decades of consciousness research. It is the part of the brain most consistently associated with visual awareness, with the perception of space and self within that space, with the subjective first-person quality of seeing. Christoph Koch, a neuroscientist who spent decades working with the philosopher and consciousness researcher Giulio Tononi, had been among those to propose this posterior region as a primary substrate of conscious visual experience. The posterior hot zone, in the framework Koch and Tononi developed, is not the place where decisions are made or words are processed. That is more anterior, more frontal. It is the place where what is seen becomes experience, where visual information is integrated into the sensation of a perceiving self within a visible world. The University of Michigan data showed that in 2 dying patients, the surge of gamma activity concentrated precisely here, in the region most implicated in the subjective experience of seeing, of being present, of being located somewhere that can be seen. The published authors were explicit on one point. They noted the location of the surge and its potential relationship to reported visual experiences in near-death accounts. They named the posterior hot zone directly. They acknowledged the correspondence between where the gamma activity occurred in the brain and what the broader body of NDE literature had documented as the most common and consistent feature of such accounts: vivid, luminous, spatially organized visual experience. And then they were careful to state what the data had not established. The correspondence was noted. The direct causal connection between the gamma surge and any specific reported experience had not been demonstrated. The paper held the finding at the level of a documented neurological event, potentially relevant to questions that had not yet been answered, located in a region whose functional significance made the correspondence worth recording. This kind of precision in published language is not evasion. It is the ordinary grammar of a scientific finding that sits at the edge of what can be formally established. The data said, the surge happened, it was concentrated here. The location is the one that consciousness researchers have associated with visual experience. The data did not say, this is why dying people report vivid visual experiences. Both of those statements belong to the record, and the paper placed them both where they belonged, the first inside the findings, the second outside the claims. To understand why the 2023 results carried the weight they did in the published literature, it helps to follow the finding backward to where it had first appeared, not in a human ICU, but in a laboratory setting, with a very different kind of subject. In 2013, Borjigan and colleagues published a paper, also from the University of Michigan, recording the brain activity of rats during induced cardiac arrest. The rat study had not been designed to investigate near-death experience in any clinical sense. It had been designed to measure what the dying mammalian brain does at the level of its electrical output, and to produce data clean enough to be analyzed in detail. What it found within the first 30 seconds of induced cardiac arrest was a surge of synchronized gamma oscillations, high frequency, organized, coherent, appearing in the cortex at a point when the heart had stopped and blood flow to the brain had ceased. The 2013 rat data was notable precisely because it was clean. Rat cardiac arrest can be induced under controlled conditions that human cardiac arrest never provides. The timing is exact. The physiological parameters are documented. The EEG trace runs without the clinical complication and noise of an emergency medical setting. What the trace showed was unambiguous. In the seconds after cardiac arrest, the rat cortex produced a burst of gamma activity that exceeded baseline waking levels in its synchronization and organization. The finding was published and discussed, and it raised a question that could only be answered with human data. The rat brain was showing the researchers something. Whether the human brain did the same thing under the uncontrolled conditions of a real ICU was a different and much harder question to answer. The 2023 human study was not designed in direct response to the 2013 rat paper, but the methodological relationship between them was acknowledged in the published literature. The rat findings provided a biological precedent, a demonstrated mechanism in a mammalian brain for this class of event. They provided, too, a template for understanding what to look for in the human EEG data and an evidentiary context in which the human findings could be situated. When the University of Michigan team reviewed the EEG records from 4 dying patients and found, in 2 of them, a surge of gamma activity concentrated in the posterior cortex, the 2013 rat data was part of the interpretive frame, not because one body of data confirmed the other. They were separate experiments with separate subjects and separate designs, but because the earlier work had shown that this kind of event was not physiologically implausible in a dying mammalian brain. The question of whether it occurred in dying human brains had been answered, at least in a small and specific sample, by the 2023 paper. An EEG electrode does not care what a person is experiencing. It records voltage differences at the scalp, tiny fluctuations in the electrical activity of the billions of neurons beneath it, summed and smoothed by the tissue and bone between the cortex and the sensor. What it captures is not experience itself, but a physical correlate of activity in the brain. The relationship between that physical activity and anything that might be called experience is the question at the center of consciousness research, and it is not a question the EEG can answer from its own data. What the EEG can say is, this region was active at this time, at this frequency, with this level of synchronization. What that activity meant, if it meant anything, is a different level of inquiry entirely. This distinction is worth holding because it is the distinction the University of Michigan researchers held in their own published text. The instrument recorded organized gamma activity in the posterior cortex of 2 dying patients. The record of that activity now exists in the published literature of 2023. The question of what, if anything, that activity was associated with in terms of subjective experience is a question the EEG data alone cannot close, and the researchers did not attempt to close it. They placed the finding in the record and named what it might be relevant to, and then they held the line at what the data had actually established. The 4 patients in the study had each been connected to continuous EEG monitoring for clinical reasons prior to cardiac arrest. They were patients in whom brain monitoring was already indicated as part of standard care. This meant the research team had access to baseline EEG data from before the arrest, allowing comparison between the patient's normal neural activity and whatever the trace showed afterward. For 2 of the 4 patients, the comparison revealed the surge. For the other 2, it did not. The asymmetry in the findings was not explained by the available data. No documented clinical variable clearly distinguished the 2 patients who surged from the 2 who did not. The sample was far too small to support any firm conclusion about why some patients showed the gamma surge and others did not, and the published authors noted this limitation directly. A sample of 4 is not the basis for a general claim about what dying human brains do. The researchers knew this. The paper said so. 4 patients is the basis for a documented observation, a finding precise enough to be placed in the published record, a result specific enough to justify further investigation with a larger sample. Science moves in this way, not all at once but in small and specific increments, each paper adding a piece to a body of evidence that takes its shape slowly over time. The 2023 University of Michigan paper added a piece. Its shape in the larger body of evidence would be determined by what came after it. What made the posterior cortex findings sit distinctly within the broader research context was the specificity of its location. The brain is not a uniform organ. Different regions have different functional associations, that have been mapped through decades of lesion studies, neuroimaging research, and direct neural recording. The occipital lobe, at the very back of the skull, processes visual information. Damage to specific areas within it produces specific and predictable deficits in visual perception. The parietal lobes rising above it are involved in spatial processing, in the sense of where the body is located in space, in the integration of sensory information into a coherent spatial map. The temporal lobes sweeping around the sides are associated with memory consolidation, with the recognition of faces and objects, with aspects of emotional and self-referential processing. The posterior hot zone encompasses all three of these regions, and the published proposal that it is the primary substrate of visual consciousness is not a casual suggestion. It is the output of serious theoretical and experimental neuroscience developed across decades by researchers who were working on the hard problem of consciousness, which is the problem of why any physical process in the brain gives rise to subjective experience at all. The hard problem of consciousness remains unsolved. This is not a fringe or contested claim. It is the acknowledged state of the field, named and described by the philosopher David Chalmers in the 1990s, and debated without resolution since. To what the University of Michigan data introduced into this ongoing question was a specific and measured event. The dying human brain, in at least some cases, appears to organize itself into a burst of high-frequency, spatially concentrated neural activity at the moment when clinical function is ceasing. Whether that activity is accompanied by anything that could be called experience is not a question the EEG can answer. Whether the location of the activity in the posterior hot zone is coincident with the visual and spatially coherent character of reported NDE phenomenology is a correspondence that the researchers named without claiming to have explained. In Ann Arbor, in the ICU where the monitoring equipment ran its continuous record, the electrodes did not know they were recording anything unusual. They were instruments doing what instruments do, measuring voltage, printing trace. The patient whose brain produced the surge was at that moment beyond any form of communication that the clinical setting provided. What the electrodes recorded was what they recorded, the interpretation of that record, its meaning, its relevance, its relationship to the older and longer and much larger question of what the dying brain might or might not be doing, belonged to the researchers who reviewed the data afterward, and to the paper they published, and to the wider community of scientists and clinicians who read it. The relationship between the 2013 rat data and the 2023 human data is worth examining once more from a different angle. In the rat study, the gamma surge appeared within the first 30 seconds of induced cardiac arrest. In the human study, the surge appeared within seconds to a few minutes of cardiac arrest onset. The timescales were not identical, but they were compatible. Both described a brief period of organized high-frequency activity occurring very early in the cardiac arrest timeline, before the brain's energy reserves had been fully depleted. This is significant because one of the proposed mechanisms for the surge is metabolic, the idea that as oxygen delivery to the brain ceases and neural energy resources begin to fail, the normal inhibitory mechanisms that regulate neural firing are disrupted before the neurons themselves become inactive, allowing a transient period of disinhibited, synchronized firing before the broader collapse of function. This is a hypothesis, not an established mechanism. It is one of the proposed explanations for why the surge might occur from a physiological standpoint, and it has the advantage of not requiring any extraordinary process, just the ordinary sequence of metabolic events in a dying brain playing out in an unexpected order Other proposed mechanisms exist. They are discussed in the published literature. None has been confirmed as the correct account. The question of what drives the gamma surge, if it can be replicated and characterized in larger samples, remains open. The question of what accompanies the surge, in terms of anything that could be called subjective experience in the patient, cannot be answered by the EEG at all. These are separate questions with separate methodologies, and the published literature holds them separately. The EEG printout from one of the two surge patients in the University of Michigan study is printed in the 2023 PNAS paper as part of its figure set. The trace runs across the page, the frequency bands color-coded in the spectrogram representation that allows different ranges of neural oscillation to be read simultaneously. The vertical line marking the moment of cardiac arrest is placed clearly on the graph. Before it, the expected activity of a brain in its final clinical state. After it, the surge, visible as a band of intensified color in the gamma frequency range, concentrated in the posterior channels, brief, indefinite, and organized. Then the silence. Then the flat trace that follows clinical death. To look at that figure, and it is accessible to anyone with access to the open literature of 2023, is to look at a specific thing that happened in a specific patient's brain at a specific moment, recorded by instruments that were in place for clinical reasons, and that captured something the researchers had not predicted, finding in quite this form. The figure does not claim to explain anything beyond what the instruments measured. It shows voltage at frequency over time in a dying human brain, with the moment of cardiac arrest marked, and the pattern that appeared in that moment visible to any reader who looks in a diagram of the posterior cortical hot zone from a published consciousness research paper. The three lobes are shaded and labeled: occipital, parietal, temporal, and a bracket marks the region where the proposed substrate of visual consciousness is located. The diagram does not refer to dying brains. It refers to the question of where in the living brain the felt quality of seeing is generated. The University of Michigan data place the gamma surge in this region. The connection between that location and the broader body of NDE research, specifically the consistent reports of vivid visual experience, of light, of spatial perception, reported by survivors, is a connection the researchers named, and the literature holds without resolving. The 2013 laboratory, where the rat data first appeared, the monitor showing for the first time the synchronized gamma spike within 30 seconds of cardiac arrest. The researchers who saw that trace leaning forward, the data sitting there in its specificity, preceded the human data by a decade of published work, of questions building on that finding, of the methodological groundwork being laid for the kind of continuous human EEG monitoring that would eventually produce the 2023 results. Scientific timelines are long. A finding in 2013 does not yield a human replication in 2014. It takes the time it takes: equipment, ethics approval, appropriate patient population, data collection, analysis, peer review, revision, publication. The 2023 paper arrived when it arrived, in the Proceedings of the National Academy of Sciences, carrying within it a decade's worth of accumulated methodological and evidentiary preparation. The question that the University of Michigan data places in the record is not a question about the supernatural. It is not a question about the soul, about what comes after death, about whether consciousness persists beyond the body. It is a more specific and more constrained question. What does the dying human brain do in its final measurable moments? And does what it does bear any relationship to what some dying patients have reported experiencing? Those are two distinct questions, and the 2023 data addresses a part of the first one, specifically the part about whether organized high-frequency neural activity occurs after cardiac arrest in at least some human patients, without addressing the second one at all. The second question requires different data, different methods, a different body of research entirely. The two questions exist alongside each other in the published literature of 2023 without being fused into a single answer, because a single answer is not what the data provides. Dr. Borgigan and her colleagues, in publishing the 2023 PNAS paper, added a documented and specific finding to a field that has been accumulating documented and specific findings for several decades. They did not claim more than the data showed. They named what the data showed. They acknowledged the correspondence between the location of the gamma surge and the region that consciousness researchers have associated with visual experience. They proposed that the finding merited further investigation with larger samples, and then they stopped at the precise edge of what had been established, as the language of published science requires. What the EEG recorded in that Ann Arbor ICU is sitting in the published record of 2023, still exactly as measured. 2 patients, 2 surge traces, the vertical line marking cardiac arrest on each graph. The gamma activity concentrated in the posterior cortex, dense and organized and brief, rising out of the arrest and falling back into silence. The monitoring equipment recorded it. The paper reported it. The data remains as it was collected in the color-coded spectrograms of the PNAS figure. Set, the frequency bands laid flat across the page, the moment of cardiac arrest marked with its vertical line, the posterior channels bright with activity in the seconds after the heart stopped. That is what the instruments found. That is what the record holds. The questions the record opens are still open, sitting quietly in the published literature of 2023, as specific and as unresolved as the day the trace was printed. In 1975, a physician in Virginia published a small book without ceremony. No research institution behind it, no clinical trial, no peer-reviewed apparatus of any kind, simply a collection of accounts from approximately 150 people who had, at various points in their lives, been resuscitated after clinical death or brought to its edge, and who had described, upon returning, experiences so consistent with one another that the author felt the consistencies worth documenting. The book was called Life After Life. The physician was Raymond Moody. The word he coined in its pages, near-death experience, had not existed in any clinical or popular vocabulary before he wrote it down. The book arrived without a framework to receive it, and there was no institutional home for the accounts it collected, no journal that would have accepted them as primary data, no methodology through which a physician or researcher could formally evaluate what the people Moody interviewed were reporting. What there was, instead, was a readership. Life After Life sold millions of copies in the years following its publication. It was translated into dozens of languages, placed in public circulation, for the first time under a single coherent label, the testimony of people who had come back from something and found that what they described to their doctors was met, more often than not, with careful silence. What Moody documented in those accounts was not chaotic. The reports drawn from people who had not spoken to one another and who came from widely varied backgrounds held a structural consistency that the book laid out without excessive interpretation, a sensation of moving through a passage of darkness, the perception of an intensely bright light that witnesses described uniformly as warm rather than harsh. In many cases, a review of the individual's own life, not sequential, but simultaneous, as though every moment they had ever lived was present at once, along with something like the emotional weight Each moment had carried for the people around them a boundary of some kind, and then a return, often accompanied by a clear and specific memory of having chosen or been turned back. The accounts were various in their particulars and consistent in their shape. This was what Moody noticed. This was what he put on the page. The medical community's initial response was measured. Some researchers were skeptical of the accounts on the grounds that subjective testimony, collected retrospectively without controls, could not constitute scientific evidence. Others were more open. The accounts were real reports from real patients, and real reports deserved something better than dismissal. What emerged in the years following Life After Life's publication was the slow construction of a research infrastructure. The first step was language. The second was methodology. Both took time. Kenneth Ring was a psychologist at the University of Connecticut, and in the late 1970s, he began what would become one of the earliest systematic research programs into near-death experiences in the United States. Ring was interested not only in the content of the accounts, but in their psychological after effects and what happened to people who came back with these memories and then had to continue living inside an ordinary life. His interviews, conducted across several years and eventually published in 1980 as Life at Death, documented consistent changes across large numbers of NDE survivors, a markedly reduced fear of death, a heightened sense of empathy toward others, and what Ring and his colleagues described as an increased orientation toward spiritual rather than material concerns. These were not subtle or transient shifts. In many cases, they were the most significant changes in a person's psychological profile in their entire adult life. They were also, across hundreds of accounts, remarkably similar in character. Ring developed a measurement instrument to bring formal consistency to this work. The Weighted Core Experience Index, a predecessor to the later Grayson NDE scale that would become standard in subsequent research, allowed researchers to assign comparable scores to reported experiences across different case populations, making systematic comparison possible for the first time. The index was not elegant by later standards, and it would be refined and eventually superseded by more rigorous tools. But it represented the first serious attempt to treat near-death accounts as data that could be organized, scored, and compared across individuals rather than as anecdotes that could only be collected and noted. This was a foundational shift. It moved the field from testimony to measurement. Ring's Omega Project, conducted in the late 1980s and into the early 1990s, extended this work considerably, examining hundreds of NDE survivors and documenting the long-term psychological profile that distinguished people who had undergone the experience from matched comparison groups. What the project found, with a consistency that its own researchers found difficult to attribute to expectation or suggestion, was that the changes Ring had first noted in Life at Death were not temporary. They persisted. People who had reported near-death experiences remained, years and in some cases decades afterward, less anxious about death than they had been before the event. They remained more empathic. Their relationships with other people shifted in measurable ways. The Omega Project placed these findings in a published record that subsequent researchers could build on, dispute, or refine. The International Association for Near-Death Studies was founded in 1981, 6 years after Moody's book. Its founding reflected a recognition that the subject had grown beyond what any single researcher could manage, that the accounts were accumulating faster than any individual institution could collect and evaluate them, and that the field needed a structure. The association established a publicly accessible archive of first-person NDE accounts, a growing collection of paper documents, and eventually digital records drawn from thousands of individuals across many countries, filed by year and maintained by a small professional staff and a larger body of volunteer researchers. It also founded the Journal of Near-Death Studies, a peer-reviewed publication that would run for over 4 decades and serve as the primary venue through which researchers in this field submitted, reviewed, and published their findings. The journal mattered in a way that was easy to underestimate from the outside. Peer review imposed a discipline that popular books about near-death experiences did not. Studies had to describe their methodology precisely enough for another researcher to evaluate or replicate it. Case reports had to distinguish clearly between what a subject reported and what the researcher interpreted that report to mean. Statistical analyses had to be carried out correctly and described transparently. The Journal of Near-Death Studies was not a major impact journal by the metrics of mainstream academic publishing, but it was a real journal, operating by real standards, and over 4 decades it accumulated a body of peer-reviewed work that constituted something a serious researcher could actually use, something the field before Moody's book had not had at all. By the early 1990s, researchers outside the United States had begun developing their own independent programs. The Dutch cardiologist Pim van Lommel, working in the Netherlands, had spent years encountering near-death accounts in his cardiology practice, patients who had been resuscitated and who described in ways that seemed to him worth taking seriously, experiences they had apparently undergone while clinically dead. Van Lommel was not a psychologist or a phenomenologist. He was a cardiologist. His interest was in the medical question of how a brain with no measurable activity could produce or support an experience of any kind. This question, rather than the theological or psychological dimensions that had occupied earlier researchers, became the organizing concern of the study he eventually designed. The study Van Lommel and his colleagues conducted across 10 hospitals in the Netherlands enrolled 344 cardiac arrest patients who had been successfully resuscitated, interviewing them systematically about any recalled experience from the period of their cardiac arrest. The design was prospective. Patients were enrolled before any report of experience was obtained, and the interview protocol was applied uniformly across the cohort rather than being triggered by a patient volunteering a story. This prospective design was significant. It meant the study was not susceptible to the selection bias that afflicted most prior research, where accounts were collected from people who had already chosen to come forward with a story to tell. The study was published in The Lancet in December of 2001. The Lancet carried it in a standard research article format: abstract, methods, results, discussion, with the full data set described and the methodology available for evaluation. The journal's distinctive red masthead sat at the top of the page, above a study that in its core finding reported that approximately 18% of the 344 resuscitated patients had some form of near-death experience as measured by a structured assessment instrument. The figure was considerably higher than popular estimates had suggested, but was consistent with what some smaller prospective studies had found. What made the Lancet publication significant was not only the methodology or the sample size, but the venue. The Lancet was and remains one of the most widely read and rigorously reviewed medical journals in the world. A finding published there could not be easily set aside. The Netherlands hospital names appeared in the acknowledgments: 344 patients, 10 hospitals. The prospective design was there in the methods section for any reader to examine. Van Lommel and his colleagues were careful in the discussion not to advance claims the data could not support. They noted the consistency of the findings, They noted the neurological questions the findings raised. They noted what remained unresolved, which was, in essence, most of the fundamental questions, and they left those questions in the published record without resolving them. This was appropriate. It was also, for the field, a significant step forward. The accounts had been in circulation for over 2 decades. Now they had a prospective study with a large sample in one of the world's major clinical journals, reporting that whatever these experiences were, they were not occurring in a trivially small proportion of cardiac arrest survivors. The years between the Lancet study and the next major methodological development were productive ones for the field, if not always dramatic. Cross-cultural research began to develop more systematically. Researchers in India, Japan, China, and Germany documented near-death accounts from their own populations and brought those accounts into structured comparison with the Western literature. What the cross-cultural record showed was a distinction between the surface features of reported experiences and their underlying structure. An Indian patient who reported messengers arriving to evaluate whether they should remain in the living world was reporting something that looked culturally specific. The figures involved carried names from Hindu theology, and the narrative frame was drawn from a tradition quite different from the one that shaped American or Dutch accounts. But the structural sequence was recognizable: an encounter, an assessment, a return, the bright light, the boundary, the persistent memory of having come back. These elements appeared across populations that had no documented contact with the prior NDE literature, and whose cultural frameworks for understanding death bore little resemblance to those of the patients whose accounts filled the INDS archive in the United States. The cross-cultural comparison work was careful to note its own limitations. Self-report data collected across different linguistic and cultural contexts carried methodological complications that the researchers acknowledged. Translation introduced ambiguity. The social and clinical conditions under which accounts were collected varied considerably between countries and between eras. Comparison was possible, but needed to be held at an appropriate level of caution. What the researchers were willing to say, and what the accumulated record by the mid-2000s supported, was that the core phenomenological features of these accounts showed a degree of cross-cultural consistency that any explanation tied to cultural expectation or prior familiarity with the NDE concept would need to account for. Sam Parnia's Aware, I study entered this history at a particular moment, a moment when the field had accumulated decades of phenomenological documentation and significant prospective data, but had not yet addressed what remained the most basic evidentiary challenge: whether the perceptions some patients reported during cardiac arrest could be independently verified against the physical circumstances of the resuscitation room where those patients lay. The recalled awareness accounts, patients reporting that they had observed the resuscitation from above, describing the positions of staff and the sequence of procedures, were striking, but in the absence of a way to verify details that the patient could not have acquired through ordinary sensory means, they remained accounts. Parnia designed Aware around a methodology intended to address precisely this limitation. The design used ceiling-mounted shelving units carrying visual targets, specific images that could only be seen from an elevated vantage point, placed at a height where a patient's body, lying on a resuscitation bed, could not have produced a view of the target through any ordinary perceptual mechanism. If a patient reporting an out-of-body experience during resuscitation could accurately identify the hidden image on the shelf, that accuracy would constitute a specific and independently verifiable piece of evidence that could not be easily attributed to prior knowledge. lucky guessing, or indirect cueing from medical staff. The methodology was not new as an idea. Researchers before Parnia had proposed similar approaches, but aware, I was the first attempt to implement it at a substantial scale across multiple hospitals. The study enrolled over 2,000 cardiac arrest patients across 15 hospitals in the United States, the United Kingdom, and Austria between 2008 and 2012. It was, at the time of its publication in 2014 in the journal Resuscitation, the largest prospective study of its kind. The 2014 paper described one case in which a patient's reported out-of-body experience was accompanied by verifiable details about the resuscitation room and the sequence of events, details the research team reviewed against the documented resuscitation record, but did not yield a confirmed visual target, identification. The ceiling shelf methodology, the study acknowledged, had covered only a fraction of resuscitation areas across the participating hospitals. Many resuscitation events had occurred in spaces where no shelf was installed, and in others the methodology had not been in place for the full enrollment period. The statistical power to confirm or rule out visual target identification was, as a result, insufficient. Aware, I had demonstrated that the methodology was practically implementable across a multi-site hospital setting. It had also demonstrated the scale at which it would need to be deployed in order to produce definitive results. The 2014 publication sat in the record alongside the Van Lommel Lancet study, the Grayson scale research, the cross-cultural comparison literature, and the 4 decades of documented accounts that Moody's 1975 book had effectively initiated. The Aware Eye paper closed with a recommendation for a substantially expanded follow-on study with better coverage of resuscitation areas, more hospitals, and a longer enrollment period. The methodology that would make that study possible, the ceiling shelves, the hidden visual targets, the structured 2-phase interview protocol, was already built. What remained was building the larger infrastructure around it. In one of the 15 participating Aware Eye hospitals, the resuscitation bay sat in a building that had been constructed in the 1960s and renovated several times since. The ceiling was not high. The overhead lights were the standard fluorescent type common to hospital resuscitation spaces throughout the UK. The shelf had been installed weeks before any of the relevant resuscitation events occurred in that room, attached to the wall at ceiling height by a hospital facilities technician who had asked no questions about what it was for. The visual target sat on the shelf's lower surface, facing downward toward the floor, invisible from the bed below and from every angle accessible to anyone standing in the room. It had been there for months. The nurses who passed through the bay dozens of times a week had never commented on it. The physicians who worked in that room had not noticed it. It was simply a feature of the ceiling, unremarkable from below, carrying its hidden image in the ordinary fluorescent light, waiting for a study that would eventually require a larger version of itself to be built. This image, the shelf in the resuscitation bay, installed and waiting, the target facing down toward a bed where no one was lying, belongs to the history of the field in a way that the more celebrated publications do not quite capture. The publications described what had been found. The shelf described what the field had decided to go looking for and how it had chosen to look. That choice, made first in Aware Eye and then refined and expanded into the study that followed it, represented something that 50 years of prior work had been building toward. Not a consensus about what the reported experiences meant, not a resolution of the question of consciousness and death, but a methodological commitment to finding evidence that could actually be evaluated. The shelf was not dramatic. It was the opposite of dramatic. It was a flat piece of equipment attached to a wall in a room where people were sometimes brought back from death, carrying a piece of laminated card that no one had yet identified from the ceiling. Life After Life had been published without a framework to receive it. The framework had been built over 50 years by a series of researchers who worked at institutions of genuine standing, published in journals of genuine standing, and held their conclusions to the evidence their data could actually support. Raymond Moody in Virginia, writing without institutional backing in 1975. Kenneth Ring at the University of Connecticut, developing the first formal measurement index. Pim van Lommel in the Netherlands, carrying his cardiologist's skepticism about brain function into a prospective study that appeared in The Lancet. The INDIA's archive, accumulating first-person accounts across 4 decades in filing cabinets and later in digital storage, the paper documents slightly yellowed at the edges of the earliest folders. The Journal of Near-Death Studies, publishing peer-reviewed work for over 40 years to a readership that was small but serious. And at the end of all of it, a ceiling shelf in a hospital resuscitation bay, installed and quiet in the ordinary fluorescent light, its hidden image facing down toward a narrow bed. The field that Moody had effectively created had, by 2014, arrived at a methodology that could in principle produce verifiable evidence. The question of what any such evidence would mean, whether it would constitute proof of perception during clinical death, whether it would require revision of established models of consciousness, whether it would resolve or merely deepen the question that Life After Life had placed in public circulation, was a question the evidence had not yet reached. The accounts were in the archive. The prospective data was in the journals. The shelf was in the resuscitation bay, and a larger study was by 2014 already in the early stages of design. There is a particular quality to a research field that has been doing its careful work for half a century without arriving at resolution. It does not feel like failure. It feels, from the inside of the documented record, like the specific patience of researchers who have decided that the question is worth the time it requires. The IND archive, with its folders of first-person accounts filed by year since the early 1980s, carries that patience in its physical form. The accounts at the front of the earliest drawer were collected when there was no standard interview protocol, no validated measurement scale, no prospective methodology, when the only thing a researcher could do was ask a recovered patient what they remembered and write down what they said. The accounts in the later folders were collected with Grayson scales and structured protocols and independent assessors and voice recorders placed on bedside tables between the interviewer and the patient. The change across those decades was not a change in what patients reported. It was a change in the rigor of the infrastructure built to receive what they reported. Kenneth Ring, in the years after the Omega Project, would speak about the near-death research field with the particular warmth of someone who had watched a serious subject struggle for serious attention over a long period and had seen it slowly acquire both. Van Lommel, publishing in The Lancet in 2001, had provided a moment of genuine institutional credibility, a major journal, a prospective design, a large cohort, a careful and limited set of conclusions. Parnia, publishing in Resuscitation in 2014, had provided the first serious implementation of a verifiable test. Each of these developments had taken the subject one step further from the domain of uncorroborated testimony, and one step closer to the domain of evidence that could be examined by a researcher who had not personally spoken to the patient and who had no stake in the outcome. The 50 years between Moody's Virginia study and the design of the larger follow-on study were not 50 years of stagnation. They were 50 years of slow, serious construction, Language first, then measurement, then prospective methodology, then multi-site implementation, then the recognition that the implementation needed to be larger still. The shelf in the Aware Eye Resuscitation Bay was the material expression of everything that construction had been working toward. A flat surface at ceiling height, a hidden image facing down, a methodology that could in principle produce evidence that testimony alone could not. Outside the hospital, on whatever evening the shelf had been installed, the corridor that connected the resuscitation bay to the rest of the building was quiet and fluorescent lit in the same way as all hospital corridors at that hour. A facilities technician walked back through it, carrying a drill and a level. The resuscitation bay door closed behind him. The shelf sat in the ordinary light of a room built for ordinary hospital work, holding its image in the ordinary dark that came when the lights were eventually turned off, waiting as the research that had been building for 50 years was also waiting for a study that would expand what had been installed in that one room to 25 hospitals across 2 countries, with longer enrollment, better coverage, a more fully developed interview protocol, and the accumulated methodological learning of a field that had begun with a Virginia physician, a book without a framework, and 150 accounts from people who had come back from somewhere and needed a word for what they remembered. The ceiling shelf in the participating Aware Eye Hospital, installed quiet, its target facing downward toward the empty bed below, was the image the field had built toward. And the methodology it carried, refined and significantly expanded, would be the one that traveled forward into the study that followed. The Grayson NDE scale begins with a question about time. Specifically, it asks whether time seemed to speed up, and the respondent is given 3 choices: no change, time seemed faster than usual, and everything seemed to happen all at once. That third option, everything seemed to happen all at once, is scored 2 points, the highest value on the scale's 3-point range. It sits at the top of the cognitive cluster, the first of 16 items, the opening of a careful instrument built in 1983 by a psychiatrist named Bruce Grayson, who had spent years listening to people describe experiences that arrived in the vicinity of death and did not behave the way ordinary experience behaved. The scale is not long, it fits on a single page, but the precision built into it, the 4 clusters, the scoring columns, the total out of 32, represents something accumulated slowly, years of accounts compared against one another, features identified and weighted, a framework constructed item by item from what survivors actually said. 16 rows, 4 clusters: cognitive, affective, paranormal, transcendental. Each item scored 0, 1, or 2. The cognitive cluster asks about time, the speed of thought, life review, and sudden understanding. The affective cluster asks about peace, joy, unity, and the encounter with a brilliant light. The paranormal cluster asks about altered perceptions, apparent extrasensory awareness, visions of future events, and the sense of having left the physical body. The transcendental cluster asks about arriving at a border, encountering a presence or being, seeing deceased relatives, and arriving at an otherworldly place. A completed form from an Aware 2 interview shows the clusters filled in row by row, the subtotals noted at the bottom of each section, the final score circled by the assessing researcher. What the form holds in those circled numbers is a standardized record of something that has not yet been given a stable place in medical understanding, an experience that occurred by the accounts of those who reported it during the period when the patient was clinically dead. Grayson published the scale in 1983. The year matters not as a date to remember, but as a marker of distance, the distance between the early, uncategorized accounts and the point at which a researcher had collected enough material to begin measuring. By 1983, there were hundreds of documented accounts. There were first-person narratives gathered in clinical settings, in academic interviews, in letters sent to researchers who had put their names to published work and received responses from people who had spent years not knowing who to tell. Grayson worked at the University of Virginia. He had colleagues in this field and a growing archive of cases, and what he built was not a belief instrument or a dismissal instrument, but a measurement instrument, a way to compare one account to another, to note the features that recurred, to ask whether the recurrence held meaning, whether an individual score represented a genuine near-death experience, or something else was not a question the scale resolved. That was not what the scale was for. What it was for was precise, consistent, comparative documentation, and that, across the following 4 decades, was what it produced. The features the scale measures did not originate with Grayson. They were already there in the accounts when he began to systematize them. They were there in the accounts Moody collected. They were there in the transcripts Van Lommel and his colleagues gathered from Dutch cardiac arrest patients in the late 1990s. They were there in the testimonies documented in Indian hospitals, in Japanese clinical research, in German and Australian and American and British studies, conducted by researchers working independently of one another across different institutions in different decades. And what emerged from that geographic and temporal spread was not a collection of entirely different experiences shaped by entirely different cultures. What emerged was a core, a set of features that appeared across accounts regardless of where the account originated or when it was given. A sense of peace, a perception of moving through darkness toward light, an encounter with a brilliance that did not hurt and did not fade. A boundary, described variously as a gate, a wall, a river, a line, that the experiencer understood without being told, as a threshold beyond which return would not be possible. And the life review, not a memory of one's life in the ordinary sense of recalling past events, but something described more precisely as a simultaneous, panoramic perception of every moment, every action, every interaction, experienced not only from one's own perspective, but from the perspective of every person one had ever affected. The emotional impact of one's choices, as felt by others, experienced directly. That feature recurs across accounts from countries and centuries that had no documented contact with one another's traditions. It appears in accounts from people who had never heard of a near-death experience before their own, who had no cultural framework for what had happened to them, and who sometimes struggled for years to describe something that language had not yet made a category for. The tunnel and the light appear in Dutch accounts and American accounts, and accounts gathered in rural India with the help of interpreters. The life review appears in the testimony of a Welsh coal miner resuscitated in the 1970s, and in the account of a cardiac arrest survivor interviewed by Van Lommel's team in a hospital in Utrecht in 1998. What varies across cultures is the population of figures encountered during the experience, the specific beings or presences perceived at the threshold. In accounts documented from India, the figures sometimes identified themselves as Yamdoots, the messengers of Yama, the Hindu god of death. Their role in the Indian accounts is structurally equivalent to the role of angels or deceased relatives in the accounts gathered in Western clinical settings, figures perceived as authoritative, perceived as connected to the realm beyond the boundary, perceived as delivering the information or making the decision that the experiencer must return. The figures differ. The structure in which they appear does not. The researchers who documented Indian NDE accounts in the late 20th century noted this specifically. The cultural content varied, the experiential architecture remained consistent. A researcher in a hospital in the 1990s, conducting interviews with Indian cardiac arrest survivors, sat across from a participant who described a scene that began the way Western accounts begin: the sensation of leaving the body, the movement toward light, and then entered a room in which figures in white robes consulted a written record. The written record contained an error. The Yamdutes had summoned the wrong person, and so the experiencer was sent back into the body, into the room, into the hospital bed where the medical team was still working. The researcher wrote the account down by hand into a case notebook. The interpreter translated steadily. The structural details, the consultation, the record, the decision, the return, corresponded precisely to the architecture found in accounts gathered thousands of miles away by researchers who had never met this team and had not published their work in a language accessible to the communities these researchers were working in. The content was distinct. The shape was the same. The Grayson NDE scale does not ask which cultural figures were present. It asks whether the experiencer perceived a deceased relative or a figure perceived as some form of spiritual presence. The specific character of that presence is not the variable the scale measures. What it measures is presence or absence and degree. And what decades of application across multiple populations have shown is that the presence, whatever its specific cultural form, is one of the most consistently reported features in the documented record, not universal, not reported in every account, but recurrent enough across enough populations that researchers who compiled cross-cultural comparison tables found themselves drawing check marks across nearly every row. The comparison tables were published. They appeared in peer-reviewed journals. They appeared in The Lancet and in the Journal of Near-Death Studies and in Resuscitation and in publications in consciousness research and in palliative care and in cardiology. They were not the work of a single institution or a single researcher. They accumulated across decades, each study building on the methodological decisions of earlier studies, each new data set adding to the breadth of the cross-cultural comparison. What the table showed was not proof of any particular interpretation of the experience. What they showed was consistency of the experience itself, consistency of reported features, consistency of sequence, consistency of the emotional qualities described by survivors in the aftermath, regardless of geography or belief system or prior familiarity with the phenomenon. The aftermath, the research on what happens to survivors in the years following a near-death experience, is itself a substantial body of work. Kenneth Ring documented it in the late 1980s and early 1990s. Reduced fear of death, increased empathy, heightened concern for others, changes in personal values and priorities, sometimes a sense of difficulty, reintegrating into ordinary life. Van Lommel's prospective Dutch study followed its cohort of 344 cardiac arrest survivors over an 8-year period and found significant differences between those who had reported an NDE and those who had not. The NDE survivors showed greater concern for others, greater interest in spirituality, less attachment to material possessions, and a substantially reduced fear of dying. These differences persisted across 8 years of follow-up. They were not the kind of differences that could be attributed simply to surviving a cardiac arrest, because both groups had survived cardiac arrests. The difference lay in whether a particular kind of experience had been reported during that arrest. Van Lommel's team was careful with this finding. The 2001 Lancet paper noted it as a documented outcome without proposing a mechanism. The research established the longitudinal pattern. It did not claim to explain it, and that carefulness, that precision about the difference between what the data showed and what the data meant was characteristic of the most rigorous work in this field across its entire history. The researchers who contributed to this record over 50 years were, for the most part, exactly that careful. Moody collected accounts, Ring measured outcomes, Van Lommel prospected a cohort, Grayson built a scale, Parnia installed shelves at ceiling height, and designed a structured two-phase interview protocol. Each step added something specific to the accumulated record. None of them claimed more than the specific step warranted. The Aware 2 interview protocol began with open-ended questioning. The first phase asked survivors simply to describe what they remembered from the period of their cardiac arrest, without prompting, without suggesting what kinds of things might have occurred. The open-ended phase was followed by the Grayson NDE scale, the 16 items, the 4 clusters, the 3-point scoring range. Both phases were recorded, both were transcribed. The transcripts were reviewed by independent assessors who classified the accounts without reference to what the primary interviewer had noted. The purpose of the independent review was consistency, a way of ensuring that what was counted as recalled awareness in one interview was counted by the same standard in another, conducted in a different hospital, by a different researcher, in a different country. Consistency in a multi-site study spread across more than 25 hospitals in the United States and the United Kingdom was not automatic. It required protocol. It required training. It required the kind of methodological care that does not appear in the results section of a published paper, but is implicit in the reliability of the data those results report. A small number of the Aware 2 interviews produced transcripts that were classified by both the primary assessor and the independent reviewer as recalled awareness accounts. These were the accounts in which survivors described the resuscitation process itself, not a dream of resuscitation, not a fragmentary impression, but a structured account of the room, the personnel, the equipment, and the sequence of events reported from a vantage point inconsistent with the physical position of the patient's body during CPR. Among these accounts, a subset was reviewed against the contemporaneous resuscitation records, the logged sequence of events, the noted number of personnel, the documented actions taken by the medical team. The comparison was conducted by the research team after the fact, after the account had been recorded and transcribed and classified, with the resuscitation records held separately from the interview transcripts until the comparison was made. The details in some accounts corresponded to what the records showed. The details in others could not be verified in either direction, not confirmed, not ruled out. What the Aware 2 paper reported was what the data warranted. Correspondence in specific cases, the limits of verifiability across the sample, the findings placed in the published record without embellishment. The physical layout of a resuscitation room in a participating Aware 2 hospital, as a recovered patient described it from memory, weeks after the event, included the positions of 2 nurses, the placement of the defibrillator cart, and the angle of the overhead light. These details were held by the research team against the room's documented layout and against the recollections of the staff present. The account was documented. The correspondence was noted. The file was closed and placed in sequence with the others, each interview transcript in its own folder, each folder labeled by case number, each case number corresponding to a patient who had survived a cardiac arrest, and weeks later, in a hospital recovery room or an outpatient interview setting, had described what they remembered from the time when, by every available clinical measure, their heart had stopped. What these accounts described, from the position above the room, looking down at the team working on a body that the experiencer understood somehow to be their own belongs to the paranormal cluster of the Grayson scale. Item 9, in the scale's numbering, asks whether the experiencer seemed to enter some other, unearthly world. Item 10 asks whether there seemed to be a special kind of communication with some being or presence. But item 7 is the one that covers what the Aware 2 out-of-body accounts specifically described, whether the experiencer seemed to be separated from their body. The three options are: no, I seem to leave my body and exist outside it, and I clearly left my body and traveled to another location. The second and third options score 1 and 2 points respectively. In the Aware 2 transcripts where out-of-body perception was reported, the description was not of a vague or dreamlike impression. It was specific. The room was described. The personnel were described. The actions were described in sequence from a vantage point that the patient's body did not occupy during the resuscitation. Grayson himself, writing about the out-of-body component of near-death experiences across his decades of research, was careful to note what the accounts claimed and what could be assessed. Some accounts could be partially corroborated by independent evidence, others could not. The ones that could not be corroborated were not therefore false. They were simply unverifiable in either direction, which is a different category entirely. The ones that could be partially corroborated by independent evidence were not therefore confirmed as literal perceptions from a disembodied vantage point. They were corroborated. The question of what corroboration established was a separate question, held open by the research, not resolved by the data. And that open holding, that careful maintenance of the distinction between what the evidence showed and what the evidence meant, was what made the serious research in this field serious. The years of cross-cultural comparison produced something that could be said plainly and without embellishment. The features of the near-death experience, as documented in the published clinical record, are more consistent across different populations than they are different. The differences are real. The cultural specificity of encountered figures is real and documented and noted by the researchers who observed it. But the structure of the experience, the movement, the light, the boundary, the decision to return, is more consistent than the differences that overlay it. What the consistent structure means is a question the research does not answer. It has proposed hypotheses. It has ruled out some simpler explanations while leaving others intact. It has not arrived at a mechanism. It has not established whether the experience corresponds to an external reality or is generated entirely within the dying brain, or is something for which the existing conceptual categories are not yet adequate. The published literature, taken as a whole, holds all three possibilities without collapsing into any of them. In 2023, Parnia proposed a change in terminology. The paper appeared in Resuscitation. In it, Parnia suggested replacing the term near-death experience with the term recalled experience of death. The difference is not merely semantic. Near-death places the experience adjacent to death, something that occurs near the threshold, but not across it. Recalled experience of death places it differently. It describes an experience recalled from the period of clinical death itself, during the window when cardiac arrest had stopped the heart, and standard clinical criteria had classified the patient as dead. The terminological shift was proposed as a clinical precision, a way of locating the experience accurately in time, in relation to the medical event, rather than softening its placement with a qualifier that implied the patient had been only nearly dead. For research purposes, the precision mattered. If the experience was occurring during cardiac arrest, during the period of clinical death, rather than in the moments before or after, then the questions it raised were different in kind. not merely in degree. The phrase appeared in the published text of the 2023 paper. It sat on the page beneath the journal's header, in the body of a paper that had gone through peer review and editorial process and had arrived in the indexed open access record of a journal with 4 decades of publication history. Recalled experience of death. The phrase is careful. It does not assert that death was crossed and returned from. It asserts that the experience was recalled from a period clinically identified as death. The distinction is the kind that researchers make when they want to be exact, when they want the language to carry only what the evidence supports and not the interpretive weight of what the evidence might mean. Parnia's use of it was a clinical act, not a metaphysical one. It was an attempt to give the experience a home in the medical record without either dismissing it or overstating it. The medical record has been, historically, an uncomfortable place for these accounts. Survivors sometimes chose not to report what they recalled, for years or for the rest of their lives, because the accounts were received with skepticism or concern by the medical professionals they told. Van Lommel's Dutch study noted this. Survivors feared that reporting the experience would lead others to question their mental stability. Parnia had heard versions of this in the accounts gathered during Aware Eye and in the testimonies of patients who contacted the research team independently. The terminological proposal in the 2023 paper was, among other things, a practical clinical intervention, an attempt to make it easier for survivors to report what they had experienced, and easier for medical professionals to receive those reports without the conceptual frameworks the existing terminology carried. Recalled experience of death. A clinical category placed in the published record, available in the Archive of Resuscitation, indexed and held. The indexed record of NDE research now spans more than 4 decades of peer-reviewed publication. It spans multiple journals, multiple disciplines, multiple countries. It includes prospective studies and retrospective analyses and case reports and scale development papers and cross-cultural comparison tables and longitudinal outcome studies. What it does not include is a consensus on mechanism. The research has established the phenomenology with considerable precision. The features, their recurrence, their cross-cultural consistency, the psychological and behavioral changes associated with the experience in its aftermath. It has established the demographic characteristics of those who report the experience. It has established, in the case of the University of Michigan EEG findings, that the dying brain is capable of producing organized high-frequency neural activity in the period following cardiac arrest in the posterior cortical regions associated with conscious visual experience. It has established in the AWARE-2 data that a small number of cardiac arrest survivors report structured, detailed awareness of the resuscitation process from an apparently elevated vantage point, and that in some of those cases, the reported details correspond to contemporaneous resuscitation records. What the record has not established is a single coherent account of what produces these experiences, or what, if anything, they indicate about the nature of consciousness at the boundary of death. The hypotheses are multiple and competing. They include neurological explanations centered on the activity of the dying brain. They include psychological explanations centered on expectation, memory consolidation, and the organizing function of narrative in traumatic experience. They include more speculative proposals about the relationship between consciousness and biological substrate. The published literature covers the hypotheses with the same careful, interested attention it brings to the data, noting what each explains, noting what each leaves unaccounted for, noting the points at which the evidence and the hypothesis do not cleanly fit. A completed Grayson NDE scale form from an Aware 2 interview sits in a research file, 16 rows, 4 clusters. The subtotals noted at the bottom of each column. The total score circled in ink by the assessing researcher. The form was filled in during a 2-phase interview conducted weeks after a cardiac arrest in a participating hospital. The patient who generated those scores had survived something: a cardiac arrest, a resuscitation, and then the experience of waking again into a world that continued without acknowledging what had apparently happened during the interval. The score on the form represents a standardized measure of an account. The account represents what the patient recalled. What the patient recalled: the light, the sense of peace, the impression of looking down at the room, the feeling of a presence at the edge of the boundary, had happened in the patient's reported experience. During the minutes when the heart had stopped, and the team was working, and the monitoring equipment was recording the body's vital signs as absent. The form is closed and returned to the file. The file sits in sequence with the others. Outside the research setting, the patient has returned to a life that is, according to the longitudinal outcome literature, likely to be somewhat different than the life they were living before the arrest, quieter, perhaps, in its priorities, more patient with others, less worried about dying. These shifts are documented. They are not uniform and they are not universal, but they appear across the outcome literature with enough consistency to be considered a characteristic feature of the post-NDE experience rather than an anomaly. The person who now walks through their days without the particular fear of death that most people carry, who feels when asked that they have already met what waits at the end and found it something other than terrible, carries that knowledge in a way that the people around them cannot see and may not ask about. The research on these experiences has been, for most of its history, quieter than the experiences themselves. It has been conducted in the margins of cardiology and psychiatry and consciousness research by small teams working with limited funding on a subject that the mainstream of medicine has not known how to accommodate. The 2001 Lancet paper moved something. The PNEA's gamma wave findings moved something. The Aware 2 publication in 2023 moved something. But what the field holds, still, is more open questions than resolved ones. It holds precise documentation of something that continues to happen in hospitals around the world, in resuscitation bays and ICUs and operating rooms where cardiac arrests occur, and resuscitation efforts succeed, and patients recover, and eventually are asked by someone with a voice recorder and a printed interview protocol whether they recall anything from the period when their heart had stopped. Some of them do. The percentage is small. The accounts are carefully recorded. The transcripts are reviewed. The classifications are confirmed by independent assessors. The files are closed and placed in sequence. And the study, having done what a study can do, having measured, compared, documented, and published, rests in the open access archive of a peer-reviewed journal where it sits alongside the 50 years of work that preceded it, all of it holding the same question in the same careful way. What happens in the dark interval between the heart stopping and the heart starting again to the experience of being? The question has not been answered. It is held in the published record, in the indexed transcripts, in the Grayson scale forms filed in sequence, in the cross-cultural comparison tables where the check marks run across every row, held in the recollection of a survivor who looked down at a room from somewhere above it and saw, with a precision that the resuscitation records later partially confirmed, the number of people working in the sequence of actions they were taking and the angle at which the overhead light fell across the narrow bed. Held in the outcome data from 8 years of follow-up, the survivors who returned from the boundary carrying a quietness about death that the comparison group did not share. Held in the terminology, recalled experience of death, 4 words that locate something precisely in time and resist the temptation to locate it any further. In a published cross-cultural comparison table, Dutch and Indian and Japanese NDE accounts are listed in parallel columns. The recurring features of movement, light, and boundary run across the rows. The check marks fall in nearly every column for nearly every feature across populations that share almost nothing else in their documented approaches to death and its meaning. The table does not interpret this. It records it